Hi, today I'm going to read mm, articles in Hugging Fish. It is my reading session where I record reading to improve my English speaking, yeah, in front of the people. Let's, let's get down to this article right now. Uh, Today I'm going to read about the articles on Gemma of fully available in open source ecosystem, which was published in June 26, 2025. This article was published, not the model itself. Yeah. Gemma was announced as a preview during Google I/O. The on-device community got really excited because it is the model designed for the ground up to run locally on your hardware. On the top of that, it is natively multimodal, supporting text, image, text, audio, and video import. Today, Gemma is fully available on most of open source libraries. This include transformers and themes. Yamlex, llama.cpp, text input in llama.cpp, text input is supported, transformers.js, olama, Google AI is, and others. This post goes through a practical snippets to demonstrate how to use the model with the library and how easy is it to fine-tune it for other domain. Model released today. Here are the Gemma 3 and release collection. What are there? 3N, E4B, E2B, IT means for instruction fine-tuning. I don't know. They are in 8 billion and 5 billion parameter. Both may be the best variant of 4B 3 and 4E 4V 8 billion parameter, and for instruction fine tuning I think this is the IT means instruction fine tune version of OpenWeight. Okay, two models have been released today with the two variant base and instruct each. The model name follows the known standard nomenclature. What is nomenclature? Is new word for me, a system of names used in art and science. uh, Nomenclature means name, known standard naming. They are called Gemma 3 and E2B and Gemma 3 and E4B. E the E preceding the parameter counts for effective. Their actual parameter counts are 5 billion and 8 billion respectively, but thanks to the improvement in memory efficiency they managed to only need 2 billion and 4 billion in VRAM GPU memory. This model therefore behave like 2B and 4B in terms of hardware support, but they punch 2B slash 4B in terms of quality. The E2B models runs in as little as 2 GB of GPU RAM, and while 4B can run on 3 GB of GPU RAM. Oh, interesting. I don't know how they did it, but that is interesting to run the 4 GB model on 3 GB of RAM. Okay, here are these base they release base and instruct variant of the size of 2 billion and 4 billion variant. Okay, detail of the model. In addition to the language decoder, Gemma 3N uses audio encoder and visual encoder. We highlight their main features below and describe how they have been added to the transformer and team, as they are referenced for other implementation. Vision encoder MobileNet V5. Gemma 3N uses a new version of MobileNet, MobileNet V5 300, which has been added to the new version of Team released today, which have features 300 million parameters, supports 256 by 256 or 512 by 512 or 768 by 768 resolution of image, achieves achieves 60 fps on Google Pixel, outperforming the PI design while using 3x fewer parameters. Audio encoder based on Universal Speech Model (USM) processes audio chunks in 160 millisecond chunks. Enable speech to text and translation functionality. Speech English to Spanish, French. Gemma 3 and architecture and language model. The architecture itself have been added to the new version of Transformer released today. The implementation branches out to the team for the image encoding so that the single reference implementation of mobile net, so there is a single reference implementation of mobile net architecture. Architecture highlight: Matt Farmer architecture, a nested transformer design similar to the Matryoshka embedding, which allows for various subsets of layers to be extracted as if they were individual model. E2B and E4B were trained together, configuring E2B as submodel of E4B. User can mix and match the layer depending on their hardware characteristic and memory budget. Per layer embedding (PLE) reduces the acceleration memory uses by offloading the embedding to the CPU. This is the reason why E2B model, while having 5 billion real parameter, takes about as much as memory as if it were 2 billion parameter model. KB cache accelerate long context processing for audio and video, achieving the 2x pre-filled compared to the Gemma 3 for video. Performance and benchmarks. Llama area score. E4B is the first sub 10 model to achieve the score of 1300 plus. MMLU score. The Gemma 3N shows the competitive performance across the various sizes E4B, E2B, and several mix and match configuration. And multilingual support. Supports 140 languages for text and 35 languages for multimodal. Okay. Demo spaces. Here is also the they have also given the spaces for the demo. The easiest way to pipe check the model is with the dedicated Hugging Face for the model. You can try the different prompt with the different modalities here in these spaces. Inference with the transformer. Install the latest versions of the team for the visual encoder and transformer to run the inference, or if you want to fine tune it. Both the team and transformer are to be installed from the upgraded version for latest library. Inference with pipeline. The easiest way to start with the Gemma 3N is by using the pipeline abstraction in transformer. Directly using the pipeline, it is the text, image, text to text. Gemma 3N for E4BIT devices CUDA and messages, row content, images, given images and given text. Pipe and it gives the output. Detailed inference with the transformer. Initialize the models and the preprocessor from the hub. Write the model generation function that takes care of the processing and prompt and running the inference on the model. Applying this chat template, then doing the inference on the model, decoding the tokens to the decoding the token ID to the tokens. Since the model supports all the modalities of the inputs, here are the brief explanation of how we can use them via transformer. Messages means for text only, we gives the role is equals to user, content is equals to type is equals to text, and give the text in the text key, and we give the model, we give the function model generation of model and the messages. Here is the model and messages. It simply accepts the model and messages, and it preprocesses it to process apply the chat template into the messages and convert it into the token and from tokenize the messages and token to the input IDs, which the model uses to generate the output. Interleaved with audio. For audio input, giving the audio input, we gives the content is per text key value. For text key, give the prompt what do you want to do with the audio, and for giving the audio input, we give the type audio, and in audio key we give the I think path of the file, uh, path of the file or URL of the file, explicitly URL of the file, and it will undo all the thing and give the output. Interleaved with image and video. In image and video, we give the type is equals to image, and in image we give the URL for the image we want to work with, and in audio we can give the prompt in the voice format or directly. Sorry, I thought there was image and audio. Interleaved with the image, we can also give the prompt via the text, and it will take care of the model generation, will take care of the encoding the images and providing the tokens, how they encode the image and to provide the token and the our prompts to the models so that it gives the answer as per our need. Okay. Inference with YAMLX. Gemma 3N comes with the 0-day support for YAMLX across 3 modalities. Make sure to upgrade your YAMLX BLM installation. YAMLX BLM. Get started with the Pigeon, Python, -m, YAMLX BLM dot generate. Given the dash model, we gives the model parameter Google/Gemma 3N E4P IT, that is the path of the Hugging Face, model ID in the Hugging Face, and maximum token is 100. Temperature, we are specifying a temperature as 0.5, and we are giving the prompt for the images. This is BLM. We are giving the prompt for the images, and we are also giving the images as the input as a URL, which download and do the same thing as the above in the transformer. And in also AD audio, it is same. We are providing the model. We are giving saying the maximum token that the model can output is 100, and giving the given the temperature 0.0. This means we do not want more deviation, higher the temperature, more the diversity in the output. We don't want more diversity, and we give the prompt as a URL for the audio. Inference with the llamas.cpp. In addition to YAMLX, Gemma 3N text only works on box with the llama.cpp. Make sure to install llama.cpp or llama from the source, and we can run as a llama server EHF, means from Hugging Face, glm org, Gemma 3N E4B IT gguf colon 8Q80, means it uses the 8-bit quantization and 0. I don't quite know what it means, but it has the special meaning, I think, as far as I remember, but I can't remember it right now. Okay. Her inference with transformers.js and ONNX runtime. Finally, we are releasing ONNX waits for Gemma 3N E2B IT model variant, enabling flexible deployment across the diverse runtime and platform for JavaScript developer. Gemma 3N has been integrated with transformer.js and is available for the version of 3.6.0. For more information on how to run model with this library, check out the user section in the model card. Fine tune in the pre-Google Colab. Given the size of the model, it is pretty convenient to fine tune it for the specific downstream tasks across the model. Is to make it easier for you to fine-tune the model, we have created a simple notebook that allows you to experiment with on the pre-Google Colab. We also provide the dedicated notebook for fine-tuning on audio tasks so that you can easily adapt a model to your speech dataset and benchmark. Hugging Face Gemma recipe. With these releases, we also introduced the Hugging Face Gemma repository. One will find notebook and script to run the model and fine-tune them. We love to see the Gemma family of the model and add more recipe to it. Feel free to open issue and create pull requests to the repository. Conclusion: we are excited to host the Google and their Gemma family of model. We hope the community will get together and make the most of this model. Multimodal, small size and highly capable, make a great model release. If you want to discuss the model in this more detail, go ahead and start the discussion right below this blog post. We'll be happy to help you. A huge thanks to Arthur Cried what is this? Arthur Ryle Rawson Strand. How can I pronounce this? Sandre and everyone at the Hugging Face will take care of the integration and make available to the community. Thank you for watching, and it is the finish of my reading session. You can comment how like my reading session. Yeah, it is just me reading the blog post, and I cannot give you more input because it is for new new to me. I have not read this beforehand and I do not know the concept of it. I just want to read it, so it will help me in the journey of becoming more confident while speaking, as English is not my first language. Okay, anyway, thank you for watching. See you next time.